and we are going to get moving. So specifically, I'm going to look at ones that were tricky for people. So a lot of these first ones were just basic derivatives, basic integration, not crazy hard for people, but we're going to dig into some of the more difficult ones that are down here. So I'm going to start with number 4, not because the math behind it's particularly difficult, but we just need to make sure we understand this concept. So what number 4 says is let g by g of x is x to the 4th plus 5x cubed. How many relative extrema does g have? So relative can be maxes or mins if it's extrema, right? And what we're looking for is not just the critical values, but we're looking for where we actually have a sign change, right? And so this is tricky for some people because they'll go, oh, set it equal to 0, the number of critical values is the extrema. Not always. You actually need that sign change there, right? So if this is g prime would be 4x cubed plus 15x squared, right? And I'm going to factor out x squared. So I would have 4x plus 15 equals 0. So I have 2 critical values. I have a critical value at x equals 0 and a critical value at negative 15 over 4. And let's think about what would happen at those. So negative 15 over 4, I can already see from the multiplicity of this, this has an odd multiplicity, a multiplicity of 1. And so it's going to have to change signs there. So I know that that will definitely be a critical value that there's actually an extrema at. This one here, I see that there's a multiplicity of 2. So that critical value actually will not have a multiplicity, or will not cross there. So because of that, I know that that is not actually an extrema, even though it's a critical value. So I really only have this one where there is a relative extrema. So that's why that's 1. A bunch of people were getting C for this, which is 2. There are 2 critical values, but there's only 1 actual extrema. So that's the first thing. Make sure you distinguish between critical value and extrema. Same thing with second derivative tests or second derivative, right? If they ask you for a point of inflection, don't just give me where the second derivative equals 0. Make sure you look for that sign change. All right, next one. This one's a little funky just because of the wording. So velocity of a particle moving along the x-axis is given by v of t as x squared minus 2x for t, and these should all be t's. Don't ask me why I didn't use all t's, because I wrote this. So t squared 2t for t greater than 0. What is the velocity of the particle? Velocity of the particle from 1 to 4. Now here's the thing. When you think average velocity, I know your brain thinks, ooh, let's find slope. But look at what we're given here. We're given velocity, and we're asked for average velocity. So I'm not being asked for an average rate of change here. I'm being asked for an average value. And the average value formula is 1 over b minus a, the integral from a to b of whatever your function is. So in this case, v of t dt. And I want this from 1 to 4. So what I need to find is 1/3, 1 over 4 minus 1, the integral from 1 to 4 of v of t, which is t squared minus 2t dt. That's what I actually need to calculate there. If they had given me position and asked about average velocity, then I would have done f of b minus f of a over b minus a. But because they gave me velocity and asked about average velocity, I need the average value of that function. So let's actually calculate this. This integral is what I'm going to work on now. So t cubed minus t squared, this should be t cubed over 3, evaluated from 1 to 4. And I want 1/3 of that, right? So t cubed is 64 over 3 minus 16 minus 1/3 minus 1. All of that times 1/3. Right, and when we actually simplify that, which you would need to be able to do here without a calculator, that comes out to be, what number was this, 5? That comes out to be 2, which is B. So that's what I want to make sure I'm distinguishing between is average rate of change versus average value, and it has to do with what you're given, right? If you're given the function and you're asked about its derivative, that's a rate of change. But if you're given the function and you're asked about the value, that's just average value. Okay, send questions as you have them. Again, I'm going through and hitting highlights, but if you see one that you know you want to talk about, please send it. I'm just looking at ones that typically have tripped people up. All right, the next one we're going to look at is number 8. So f is defined by f of x equals x squared plus 3bx, where b is a constant. The tangent line at x equals -2 is parallel to the line that contains 3, 5, 4, 7. What is the value of b? So remember, tangent line, we're talking about slope of the tangent line is the derivative. So let's think about this. What I know here is that the slope of f needs to be the same as the slope between these because they're parallel. So I'm going to start by finding the slope between those 2 points. So that would be 7 minus 5 over 4 minus 3. So that slope is 2. So this tells me that f prime of negative 2 should equal 2. Right? My slope there should be equal to my derivative there. So let's find f prime. So f prime would be 2x plus 3b. And I know that when x is negative 2, that this should equal 2. They should have the same slope. So this would be negative 4 plus 3b equals 2. 3b equals 6. So b equals 2. And you could always check yourself here, but that would be c. b equals 2. All right, let's look at the next one. This one is very key for people, mostly because it's a weirdo function. So what we're going to do is think about when in doubt, what do you do? And what I'm always going to tell you guys is when in doubt, graph it out, okay? So I'm giving you this function m, absolute value of t over t, where t does not equal 0, and it equals 0 at 0. The reason why is this would be undefined at 0, so it can't have that equation throughout, but that's defining it, so it's defined at every point. So what's the integral from negative 1 to 4? So that's what I need to think about here, is what is this integral? So I'm actually going to draw this. So think about making a table of values here, and I'm going to go from negative 1 to 4. So negative 1, 0, 1, 2, 3. Okay, so let's find t and m of t. So if I plug in negative 1, I'm going to get negative 1 over, or the absolute value of negative 1 over negative 1, which is negative 1. I know at 0 it equals 0. They tell me that right here. And then I'm going to plug in these other ones. So 1 over 1 is 1. 2 over 2 is 1. 3 over 3 is 1. So here's what I'm getting. I'm getting this look to this function. So it has x equals negative 1 up to 0. At 0, it's defined right there. And after 0, it's defined up here at 1. And the reason it's flipping signs there is because of the absolute value. You could break that up and rewrite it as a piecewise function, but I think the easiest thing to do is just graph it. So now think about actually finding this area. We're going from negative 1 to 1, 2, 3, 4, right? This area is negative 1. This area is 4. So the combined integral there is negative 1 plus 4, which is 3. So really with any of these, when you're in doubt, try to graph it. With piecewise, you're usually going to wind up breaking up your integral into parts, but when you're in doubt, graph it out. All right, send questions on that. I'm just keeping an eye on the chat here. All right, next one that I want to look at is an area one, which is kind of strange for people. So this is the next one I want to look at, number 11. The graph of H consists of a semicircle with endpoints 0, negative 4, and 4, negative 4, as shown in the figure above. What is the integral from 0 to 4 of H? So, could we do a U sub for number 8? Let's go back to that. U sub for number 8. On number 8, we're not actually doing any integrating. By the way, somebody sent in that question. That's why we're asking that. On number 8, we're not actually doing any integrating. And a U sub, you're only going to do when you're taking an antiderivative or taking an integral. So unless you're doing an antiderivative, you don't want to wind up doing a U sub there. If that doesn't answer your question, send me another one in the chat of where you think you do the U sub and we can come back to it, okay? Or we can talk about it in class tomorrow. All right, number 11. Again, so this is H right there, and we're trying to find the integral from 0 to 4. So what I'm looking at here from 0 to 4 is I'm looking at going from 0 to 4, and I want this area here, right? The area between that and the x-axis. So here's what's tricky for people. The tricky part is that we've got to look at what's going on here with this part we're subtracting out. So I'm going to first find this whole area. Okay? So that whole area is 4 times 4, right? Which is 16. So the area of that square is 16, and it's negative because it's below the x-axis. So my whole area there is 16. Now what I'm going to do is I'm going to say, okay, I'm taking that whole rectangle and I'm subtracting out this area. So this is my semicircle, right? And I'm subtracting that area out. So I'm saying, all right, so subtract that out. This would be a semicircle with a radius of 2. So there's my radius. So that'd be 1/2 pi r squared, right? So that would be 2 pi. And we're subtracting that out. So if this area is negative, the whole thing, and I'm trying to subtract that out of the negative, I'm really subtracting a negative 2 pi. So this really becomes negative 16 plus 2 pi, because I'm adding 2 pi back in there. And so this is b, negative 16 plus 2 pi. So the whole thing's negative 16, and then I'm adding 2 pi back in because that area is not being removed. All right, continue to send questions as you have them. If you can send me a number before I get to it, that's even better. So like if you want to look at number 20 and we're on 12, this would be a good time to send that, okay? All right, next one is number 12. An object moves along a straight line so that its acceleration is given by this. At time t equals 0, the velocity is 12, and its position is 0. What is the position at t equals 3? So you have to think about this. We want position. We're given acceleration. So we're given the second derivative, and we want to work backwards, right? That's what we're trying to do, is work backwards to that. And I'm given some initial conditions. So this is my initial velocity. So if I integrate acceleration, that's going to give me my change in velocity. I will need to add in my initial. Then the object's position, this is my initial position. Okay, so that's going to help me with that. So let's take a look at this. So a of t, so I'm going to integrate that first of all. So the integral of acceleration, integral of 4t, is going to be 2t squared, right? So this is 2t squared plus c. So that is my velocity function. Okay, that's my velocity function. I know that my initial velocity is 12. So here's what I know. I know that this equals 12 when t is 0. So c equals 12. So my velocity function now is 2t squared plus 12. That's the velocity of this particle. If I want position, I need to go backwards again. So the integral of position with respect to time would be t cubed with a 2/3 out front plus 12t plus c. And they tell me that my initial position is 0. So I know actually that c is 0, right? So c is 0. So if I want my position at 3, I'm going to plug into this. So it's going to be 2/3, 3 to the 3rd, plus 12 times 3. So 2/3, 3 to the 3rd, that is 2/3 times 27, which would be 18, plus 12 times 3, which is 36. So that is 54. My initial position should be 54. Okay, continue to send questions as you have them. All right, next one we're going to look at is 14. 14 is a weird question. So here's what 14 says. The graph of the function y shown above consists of 3 segments. If the function k is the antiderivative of y, so this is y. K is the antiderivative of y, and k of 3 equals 3. So think automatically that's initial. For how many values of c will k of c equal 4? Okay, so here's what we need to think about, and this is kind of strange. If k is the antiderivative, right? That means y is the derivative of k. So what I could say is that k prime equals y. okay? So what I want to know is I want to know what my k value here would be. And what we need to think about is that we know k of 3 is 3, so that's like your initial condition. So remember that we're using initial plus net change, right? Anytime we're talking about accumulation, we're talking about initial plus net change. I know that my initial here is 3. So I'm going to say 3 plus, let's see what our net change is. The integral from, this occurs when k is 3. So from 3 to some x value of k, right? And let's say that's k of t dt. And what I want is for that to equal 4. So what I'm really saying is, for how many places under this curve would this integral, the integral from 3 to x of k, equal 1? Okay, what I'm really saying is, how many times would that equal 1? So we need to really think about this. We're starting at 3. So if I start at 3 and I accumulate area to the right, that whole area that you're accumulating is positive, correct? So this is all positive, positive, positive. So if it's always positive, that means that k is always increasing. And so what I know there is that would only equal 1 once. Because if this is at 3, it's going to only equal 1 once. It's going to keep accumulating higher and higher. So it will happen one time to the right. Now let's think about going the other way. So if I go backwards here, I know that this area is below the x-axis, but since I'm going to the left, this would actually wind up all being positive, 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 because I'm going to the left of 3. So because of that, it's the same argument. We are increasing that whole time from our initial value. And so if we're increasing from our initial value, again, it's only going to equal 1 one time. Because if this is 3, going this way, it's only going to be 1 higher at one point. So because of that, this equals 2. There would be 2 times, 1 to the right and 1 to the left, where that value would be 4. I know that one's a weird one, so send questions if you have it. I'm going to give you guys about 30 seconds on that one if you wanted to send in any questions, and then we'll move on to the next one. But I know that one's weird, so I want to give you a second to think about it. / so I can drink my bubble tea. Okay. Keep sending questions if you still have them. All right, slip fields we're pretty good on. Number 17 is wacky. Number 17 looks wacky. So function y equals e to the 7th minus 3x plus 1 is a solution to which differential equation? I will tell you guys, you're not going to figure this out just by taking it and trying to come up with an answer magically. You need to test your answer choices here. That would be your best solution. So this is y. And all of these equations involve y prime and y double prime. So the first thing I'm going to do is I'm going to find that. Y prime would be 7e to the 7x plus or minus 3. Y double prime would be 49e to the 7x. And now I'm going to plug these in and I'm just going to see which one works. Okay, I'm going to see which one works. So let's start with A. So A says y double prime, which would be this, plus 7y prime minus 21 equals 0. Let's see if that's true. So 49e to the 7x plus 49e, I can already tell you this isn't going to be true, minus 21 does not equal 0, so it's not A. All right, let's try B. So for B, I'm saying y double prime, which would be 49e to the 7x, plus y prime, 7e to the 7x minus 3, plus 21 equals 0. No way, Jose. Not going to happen. Let's try C. Double prime minus 7y prime plus 21 equals 0. Let's see if that works. 49e to the 7x minus 49e to the 7x. That's great because those cancel, right? Plus 21, that's no bueno. Those don't cancel. So it's not that. So you know what it's got to be? It's got to be D. And D would fix our problem from this one, which is that the two 21s combined. In D, that wouldn't happen because it's minus 21. So again, just check them, right? I would not expect you guys to solve that one by hand. It's not going to happen. Check them and see which one actually works. All right, next one. And I give you this one only because I know this is this is a derivative that we forget. So, if f is sine inverse of x, what is f prime of 1? These two derivatives are your most likely to be forgotten. So, derivative, let's get a pen. Derivative of sine inverse of x is 1 over the square root of 1 minus x squared. Here's how I remember this. Ready? Let's do a different color here. Sine inverse starts with an S. This should have a square root and a subtract. S, S, S. Okay? Sine, square root, subtract. Let's do the same thing for arctan. Tan inverse, not that we need it in this question, but it's worth talking about, is 1 over 1 plus x squared. Notice there's no s, so there is no square root. There's a t, which looks like a plus sign, so there is a plus sign. Okay, so f is sine inverse of x. What is f prime of 1? So f prime of x is 1 over square root of 1 minus x squared. So f prime at 1 would be 1 over square root of 1 minus 1 squared, which does not exist, is undefined. Okay, keep sending questions if you guys have them. I know I've still got more people with me than I've had the last couple days, which is great. Okay, again, these are ones we've been doing pretty well on in class. Let's look at 23. So 23 says figure S is the shaded region here, bounded by square root x and y equals x minus 6, as shown. Which of the following gives the volume of a solid generated when S is revolved around the x-axis? This one is tricky because we know when we do this, we're talking about like top minus bottom, right? In this particular function, or in this particular region, the tops and the bottoms flip around a little bit. So let's think about this. This is going around the x-axis. I know you guys love my drawing skills, so let me draw a little bit. So it's going to kind of look like this. Okay? It's going to be sort of like a cup, but then it's going to have a cone missing out of the top of it. And if you think about your radius here, top minus bottom, that is square root x minus 0. But if you think about it out here, now it's square root x, and then this is x minus 6. So we actually have two different scenarios here, and we need to break this up. So I need to break it up right here. And here, it's a disc. And here, it's a washer. And I know that you cannot see that. Okay, here it's a washer. So you really need to look at this kind of as two separate things, only because what's on the bottom switches, right? And so let's take a look at that. So I know that I would need to do the integral from 0 to 6 for this. And so that's going to be the integral from 0 to 6, pi times my radius squared. My radius is just the square root x minus 0 there. So that's the integral for the first part. The second part, I would be doing pi times the integral from 6 to 9 of, now let's take a gander at this. My outer radius squared is going to be square root x squared. My inner radius squared is going to be x minus 6 squared. So that would be yours for the second part. So you need to put those together. So looking at my answer choices, I'm going with answer choice B, because that's pi times the integral from 0 to 6 plus pi times the integral of 6 to 9 of that. On A, they forgot all the squareds. On B, they treated it like it was just a washer through and through. And on C, they treated it like it was going around the y-axis, which it's not. Okay. All right. So let's look at another one. Let's look at 27. This was a free response 2 years ago, and it caused mass chaos. It was the funnel problem that came from nowhere, and people freaked out. So let's talk about it. Inside of a cone, or of a funnel of height 10, has circular cross sections. Anytime you see cross sections, I want you guys to think about the fact that this might be volume, and that all volume is the accumulation of cross sections. I know I've done this a million times, but I'm going to get out my phone. This is just paper, right? Printer paper. So I'm saying that's the area of one of these. But if I stack up all the areas and accumulate them, that would give me the volume. So that's what I want you guys to think about when you see cross sections, okay? So the radius of the funnel is given by R, and that's right there defined for you, where H is, I kicked it, between 0 and 10. The units of R and H are inches. The funnel contains liquid that's draining, and at the instant when the height is 3, the liquid is decreasing at 1 inch per second. So that's dH dt. What is the rate of change of the height with respect to time? So, that's dr dt. Mrs. G, read the problem. Okay, so they give me this formula for radius. They don't ask me about volume. So this actually, I don't need to use that. But on the actual free response that this is from, you did. So they give me R. So R is 1 over 20 times 3 plus h squared. So what I'm going to do is I'm going to find dr dt because I know that and I want dH dt. 1 over 20 times 3, derivative of that is 0. 1 over 20 times h squared, the derivative of that is 1 over 20 times 2h dH dt. Now they tell me at this point that the height is 3, and I know this is 1/5. So 1/5 is 1 over 10 times 3 dH dt. So I've got 1/5 equals 3/10 dH dt. Multiply by 10/3, so I get 10 over 15 equals dH dt. And actually, the radius is decreasing, so this should be negative, so that should be negative. So this should be negative 2/3 inches per second. Okay. Last one on these of the non-calculator that I want to look at is number 30. Which of the following limits is equal to the integral from 2 to 5 of x to the 6th dx? We spent a lot of time on these. We did a bunch of them. If this is something you still need more practice on, lots of stuff on my teacher site or on Miss Baldwin's teacher site on it. But this is definitely something that you guys are going to see. So, first thing I always look at is the width of my interval. So this is 2, that's 5. So my interval width is 3. So what I want to see in my limit is 3 over n as my width. And so anyone where it's only 1 over n, I'm going to cross out because that would tell me my width is only 1. Now, I need to plug in to my formula. So I know my function is x to the 6th. And remember that what we're going to do is we're going to take a plus k delta x, and we're going to put that in to our function for x. So our a value is 2 plus k delta x is 3 times k over n, and I should be raising that to the 6th, so that should be c. All right. So again, send questions. We're going to do a couple calculator ones, and then I'm going to look through and see if we have any free response questions. But I wanted to focus on multiple choice tonight because we've done a lot more free response practice and just making sure you guys are okay with these. Okay? All right. So let's look at the calculator section. You may not use a graphing calculator in all of these, but you can use it. And you'll have 3 minutes per question for this part. So I'm going to start with 78. The second derivative of the function is given by f double prime of x equals cos 2x plus sine x squared. How many points of inflection does the graph of f have on the interval from 0 to 4? And this is really tricky, and it's really a question of making sure you're looking at the graph well. So this is f double prime. If I want points of inflection, I want points where the second derivative actually changes signs. So this is my second derivative already. So what I'm going to do is I'm going to graph that, and I'm going to see where it changes signs. And I know you guys love nothing more than watching me graph on this calculator. So cos 2x plus sine x squared, and I know already that you guys are in radian mode, right? So I'm going to graph those, and it tells me that my interval is from 0 to 4. So in my window, so I put that into y equals, in my window, I'm going to make my window only go from 0 to 4. So that I only see that stuff that I want. Now, I'm going to come into you guys so you can see this. Okay, so let's look at points where this crosses. Ready? So I see 1, 2. That almost looks tangent, and that looks like it probably crosses there. But I can't tell from this. So what I need to do is I need to explore more. So I'm going to change my window again. I'm going to change my y max and y min. This is not going higher though. So I'm going to make my y min -1 and make my y max maybe 1. And I'm going to really look at what happens on the x-axis. So there's 1, 2, 3, 4, 5. And I can see this actually crosses 5 times. So what I want you guys to do here is really zoom in and make sure you're sure about something before you commit to it. This crosses 5 times. So just look at your graph and see where it crosses. All right. Next one of these puppies that I highlighted. And again, send more questions if you have them, right? 86, the velocity of a particle moves along the x-axis is given by this. Which best describes the motion of the particle? At 2. So it's asking me about the direction it's moving. The direction something is moving always comes from its velocity, whether that's a positive velocity to the right, a negative velocity to the left. So I'm going to start by finding v of 2. Do not try to do this by hand. Throw it into your calculator. That's what I'm going to do. So square root of e to the second plus cos of 2 is 2.3. So v of 2 is 2.302. Since that's greater than 0, right, therefore particle is moving right in a positive direction. And you don't need to write this. I'm just doing this so you guys can see it. So I already know it's not moving to the left. I'm just checking messages really quick, guys. Sorry. I already know it's not moving to the left. Now, I want to look at what its acceleration looks like. So let's look at that. Please don't do this by hand. You can, but it will save you time when you have your calculator not to. So acceleration is v prime, right? Acceleration is v prime. Again, they didn't give me a, so I need to define it in terms of v. So v prime of 2 equals, in your calculator, do not do this by hand. Hit math, and then just go down to 8 and deriv, right? And I'm going to type in there. So d dx, that's my variable, of square root e to the x plus cos x. And I want to evaluate that when t is 2. So there's what I'm typing in. Hit enter. And that comes out to be 0.4498. So that's 0.4498. That's a positive acceleration. So I can already tell you that this is b. It's moving to the right with a positive acceleration. Now I'm going to add a question onto this. My question is this speeding up or slowing down? Think about that for a second. Is this speeding up or is it slowing down? So here's what I would think. Velocity is to the right, and it's accelerating to the right in a positive direction. Because they have the same sign, it's speeding up. If I'm moving to the right and I'm moving faster to the right, or I'm accelerating to the right, that's going to be a positive speed, right? Or an increasing speed. If I'm moving to the left, but I'm accelerating that way, these are working against each other, and that's going to be slowing down. So this would be speeding up. And that's something you could see. Okay. Last one of these multiple choices, and then we'll see if you guys have any free response questions, and then we are out for our last live stream. The graph of the function f is shown It has horizontal tangents at 3 and at 6, so that tells you that really is a max, that really is a min. And g is the integral from 0 to 2x of f. What is g prime at 3? I am taking the derivative of an integral here, which I'm excited about because I like doing that. So g of x is the integral from 0 to 2x of f of t dt. And I want to find g prime. So whenever you take the derivative of an integral, remember that they're inverse operations, so they undo each other. So you're going to plug in your bound, multiply by the derivative of the bound. So this is going to be f of 2x times the derivative of that, which is 2, minus f of 0 times the derivative of 0, which is 0. So that goes away. So g prime is really 2f of 2x. They want g prime at 3. So g prime at 3 is 2f of 6. This is f. F of 6 is negative 1. So this is 2 times negative 1, which is negative 2. All right. Those, my friends, are all of the multiple choice that I picked out as some of the more difficult ones. I am sure that you can see that from the diagnostic test to this is a lot more straightforward. But I'm going to sit here and hang out for a while. I want you guys to send me any last questions on the multiple choice, on the free response, anything. My plan in class tomorrow is literally to do last minute reminders, do a quick activity, and then give you guys the time to work. So whether you want to work more on these, talk to me about these, work on secure exams, you're going to have almost the whole class to do that. So, yeah, I'm going to hang out for a couple minutes, and you guys send anything along either via Remind or the chat on YouTube, and I will be here. Okay, number 9. Sweet. I love questions. Number 9, non-calculator part. Let's look at it. Maybe we'll get there. Okay, number 9. I see that we asked about it. Was there a specific question, or do we just want to go over it again? Just shoot me a message and let me know. Specific question, or do we just want me generally to go over it? I'm just going to go back through it quick because it's not one that takes a long time to go through, generally. Okay, cool. All right, so I'm actually going to erase all this stuff around here just to give us some more room. Okay, so here's what it says. It says, given this piecewise function, which looks like this, which looks wacky, find the integral from -1 to 4. So, if you remember how to break this up into a piecewise function, have a blast. Go for it. But what I always say is if you're in doubt, graph it out, make a table of values. So I want the integral from -1 to 4. So let's make a table of what this looks like at least. And -1 to 4, you can do some values around that too if you're not sure what it looks like. So I'm going to do like maybe -3, -2, -1, 0, 1, 2, 3, 4. And I'm going to plug those values into m. They already told me at 0, this is 0, so I know that. Plugging in when it's positive is really easy because it's just 1 over 1, 2 over 2, 3 over 3, 4 over 4. So all of these are 1. And when it's negative, it's still going to be a value of 1 because you're dividing a number by itself, but the absolute value makes your numerator switch to a positive sign, even though your denominator is positive. So these are going to be -1, all of them. So you get this weird looking function where at 0, it equals 0. Anywhere up to 0, it equals -1. and anywhere to the right of 0, it equals positive 1. And the reason for that, again, is t over t, you're always dividing something by itself. The question is, does the absolute value switch the sign or not? So positive 1 when it doesn't switch the sign, negative 1 when it does switch the sign. So now I want to find the integral from negative 1 to 4. And if you still have questions on this one while I'm explaining, send them back. So keep sending them. So there's negative 1. And 1, 2, 3, 4. And remember here that we're talking about area, but this is at negative 1 and that's at positive 1. So when I take this area, that's just a 1 by 1 square. So that's negative 1 because it's below the axis. And this is 4 by 1, so that's positive 4. So the integral there, if you sum that all up, is negative 1 and 4. Add those together, and that becomes positive 3. If that still doesn't make sense, or there's a specific part of that question that doesn't make sense, send it along. But that was a really good question to ask about, because that one is really just about visualizing what the picture looks like. And send others have them. Okay, good. I'm glad that makes more sense. Graph it out, because you would not have a calculator for that. 14. Yes, we can do 14. I love all these questions. Okay. 14, 14, 14. Just generally, 14's a beast. All right. So let's just talk generally again. I'm going to erase all of this. So here's what I would think about on 14. Okay. It's all about understanding basically the fundamental theorem, which is the way that derivatives and integrals relate to each other. So they tell me that this is y, and k is the antiderivative of that. So if k is the antiderivative of y, then y is the derivative of k. So k prime equals y. Or the antiderivative of y equals k. Does that make sense? Hopefully. And we know k of 3 is 3. So that's an initial value. For how many values of c does k of c equal 4? Does your whole value equal 4? So what I'm basically thinking here is initial plus net change. My initial value I know is 3. And then I would need to take the integral of y from 3 to some number. I don't know what number. And I want that to come out to equal 4. So I'm saying, at what time would k equal 4, knowing that the initial value is 3? If that doesn't make sense, send me another remind. But again, we're saying, when would k equal 4? I know the initial is 3. So I need to know at what point would my initial plus my net change equal 4. So what this says to me is that I need my integral from 3 to x of y to equal 1. I'm just subtracting this over to the other side. Because if you're starting at 3, what you need is for that accumulated area to be 1 more to get 4. Starting at 3, you'd be adding 1 more unit of accumulated area to get 4. So that's what I'm going to think about. I'm going to say, okay, starting at 3, I know my value is 3. I'm going to think about the area I'm accumulating. If I go in a positive direction, if I go this way, I'm accumulating positive area all the way over, right? That's positive area. So you're going to get to a place where it definitely equals 4 because you're starting at 3, you're accumulating positive area. I'm not sure where exactly, but I know it would happen once in here because you'd be adding 1 unit of area. Now we got to think about what if we went the other way. So from 3 going this way, I know that this area is below the curve or below the x-axis, right? So technically that's a negative area. But since we're integrating from 3 that way, this would also be a positive area. And so I know from 3 going that way, I'm going to add in 1 more unit of positive area 1 time. So once in here. And so that's why it comes out to be 2 different places, because we know that you would add that unit in once. All right, good question. So the question was, how do you know the bounds? How do you know the bounds? It's because this is my initial value. K of 3 is 3. So I don't really know what my upper bound should be. I'm not sure about that. But I do know my lower bound, because my lower bound is where my initial value is. And they tell me that the initial is 3, at 3. So my lower bound is 3 because that's where the initial occurs. So lower bound's usually your initial. And whenever we talk about initial, we'd say like f of a plus the integral from a to some value, maybe b, of f prime of t dt. Because we're saying starting at a, you have this, and then accumulate starting at a, how much you go up from there. Ask more questions on that one if you need to, or other people, feel free to send messages. Again, because these are tricky. That one in particular is probably the hardest one on this whole multiple choice. Just to conceptualize it is hard. I totally agree. It is just weird. It definitely is weird. And it's really about understanding accumulation. You know what I mean? It's about understanding your initial plus your net change. And that's what it comes down to. This would be probably a pretty highly missed question. Other questions. These are great. These are really, really good questions. Even on the free response, I know we didn't go through them all. You guys had the keys to those, but if you had questions specifically on that. I'm going to give it about another minute. That was just crazy math. I agree. What else? Anything? All right, while I'm waiting for you guys, I will tell you, I will be in my room 1-2 tomorrow. Even 1-1, I have a class, but they're taking a quiz, so come. 1-2, I'm free and in my room. Your class, obviously, I will be there. 3-1, I'm in my room. 3-2, I'm going to see if I can steal someone else's room, because technically there's something in my room. 3-3, I'll be in my room. And 4th block, my class is quizzing, so you're still welcome to come. I will also be after school. We will not live stream tomorrow because your homework tomorrow is to chillax and do any last, lookovers. But I don't want you cramming unless you've put it off too long, in which case, that's my are you serious look. All right, anything else? Remember here, I was going through some of the hardest ones in this. So if some of these seemed hard, again, I picked ones that were hard on purpose. All right. I will see you guys tomorrow. Send me more questions throughout the night. I will be up. I have to watch Westworld anyway. So just send me questions, and I will see you guys tomorrow. Big day coming. Have a good night.